Hey guys, Stevie Stroh, and we're back for another Programming in Basic chapter. We're going to do chapter 31 now, which is called It Don't Mean a Thing If You Ain't Got That String. And I just want to let you know that I have intentionally skipped chapter 30 because it was just way too complicated for me. I didn't understand it, and I am not going to be able to explain something I don't understand. So whether or not I feel that the information is useful in any game that I would program, I know the goal of this series is for me to make a game, but I am not steering my judgment or decisions on what to cover or not to cover based on if it'll apply to a game I want to make or not. I just felt that I completely do not understand sines, cosines, tangents. I don't understand trigonometry. I don't understand radians. I do understand exponents. However, since I literally do not fully understand it, I am not qualified to attempt to explain it to you. And also it made my head explode. And also, I'm not going to use it, but the only reason why I'm not covering Chapter 30 is because I'm not qualified to cover it. So hopefully for the people who understand that kind of stuff and the people who could benefit from that, you are smarter than I am to be able to translate what's in the page to what you can utilize those commands for in BASIC. But what we will show you today is some more stuff with string manipulation, which I find to be really cool. So this chapter is called It Don't Mean a Thing If You Ain't Got That String. And the new command that we are going to learn now is a command called string. And so there's an actual string variable that you can create that's called string. And with string, you can create a string of variable length based on a certain character. So you could create a string of a whole bunch of the letter A, either by putting the letter A in quotes, or you could also create a string of repeating letters or symbols based on the ASCII code of that character. So, for example, the letter A is character string 65. So just to give you an idea of what Willis is talking about, if I said print string 13 comma A, this should print 13 A's on the screen. Now if I said print string 13 comma 65, actually 65, I'm trying to remember ASCII by heart. But if I do that, say what? I know the frickin' book tells us how to do that. Just give me a BS error. Tell me that I'm full of BS, huh? All right, I think I spelled string wrong. Okay, print string, 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 13 comma 65. And then there you go, right? So the 13 says print 13 characters, and I can either wrap the character in quotes, meaning I'm typing it from the keyboard, or I could use the ASCII value of that character. ASCII is a code where different characters and symbols all have a numeric value between 0 and 255 to represent them. There are some I just happen to remember by heart. So I know 32 was the space bar, capital letter A started at 65, lowercase a was 32 higher than that. The numbers started at I think 48 for 0, 49 for 1. So there was a handful of ones I remembered from heart from just doing stuff back in the day. And I believe ASCII is maybe covered towards the end of the chapter. I've also touched on ASCII a little bit once or twice in some of my chapters. So the cool thing about string is that you can generate a string of characters very quickly. Instead of having to say, a string equals a 13 times, you could say print string 13 comma quote a, for example. So that's kind of how that command works. And there are some pretty good examples in the book. So it says the length of the string of characters you can print is from 0 to 255. 255 is the longest string length that Color Basic will support. Also happens to be the longest line number you can support. The character can either be a string expression for a character or a numeric expression for the ASCII code. If you use a string constant, enclose it in quotes. The number of characters displayed depends on the number you specify in length. Which characters you use depend on either the character or the ASCII code you specify. And it says, see the appendix for a complete list of ASCII character codes. And then they give us an example here on how to jazz up a line program by printing a string of 13 stars, then printing the word lines, and then later on they have us go back and print another 31. So this one prints 13 stars, this one prints 31 stars based on the character value, the ASCII value of 42. So that program that is going to have us run right now is the one I believe I have already typed in and created. And I believe this one is Chapter 30, Program 1. So we'll go ahead and take a look at that. And we'll see what Willis is talking about. I'm going to list the program. It's exactly the same as it appears in the book. We clear the screen. We say X string is a 13 character length string made up of asterisks. We then print at line location number 96, we print 13 asterisks. We print the word lines. We then repeat the string, which is 13 more asterisks. So we should see lines somewhat centered, wrapped in a series of asterisks. And then we say here that Y strings is going to be 31 characters long based on ASCII code 42, which happens to be an asterisk. We then print at location 384, which is somewhere down here towards the bottom, that string of 31 asterisks. We pause for the count of 1,000, and then we draw an intersecting X with the line command. So that's what this program is going to do here. See, there's our strings. You saw it. The pause might not have been as long, so if we edit line 9 and we change this to, let's say, 9,000, so we get a nice longer pause. Here you can see this was the 13 character length string. Here's the word lines. Here's the 13 character length string. This is the 31 character length string, which happens to completely match this one here. So string can create a string based on repeating symbols for you. So kind of cool, right? So that's a decent example of what string does, right? And then it asks us to do a do-it-yourself program, which I didn't do because, quite frankly, I'm lazy. Now, here is another really cool command called INSTR. And so INSTR or INSTR allows you to scan the context of a string variable for a matching keyword and then notify you when it happened. And so it will start at a particular position of 0. It will scan through the length of the screen, and then when it finds the matching search word, kind of like a Google search, and when it finds the keyword you're looking for, it will tell you what position within that character the word appeared. And so it's a really cool thing to find text within text. So when you've got string variables and you want to find a certain keyword that might be inside a sentence, for example, this is a cool thing to do. So it says that you have to specify a position, and a position can become between 0 and 255, which is the maximum length of a string. The search string is the string you want to search. So if, like, for example, a string, if I have a string called a string, I want to tell it I want to search through a string. And then what's the target? The target is the string for which you want to search, meaning what's the keyword I'm searching for. So now when it does this, you are going to get a value back of either 0 or you're going to get a value of the position of where you are. So it'll return a 0 if the position is greater than the number of characters in the string. So if I'm trying to search at position 13 on a 12 character long string, it's going to come back saying not there. If the string I am searching for is not there, meaning null. Null means not there, does not exist. So if I look for the word apple and the word apple was not in the string, it'll come back with the result of 0. the search string, excuse me, the string I'm looking for. So if I say search for a string and it can't find a string, or the value of a string is nothing, I'll get a 0. And if I can't find the target, meaning I can't find the word I'm looking for, if any of these conditions happen, it's going to return a 0 value, meaning for whatever reason, what you're trying to find, I just could not find it. And so this is an interesting program that then creates a situation where you can create the text you want to search. You can enter in a long string of text, and then you can say, well, what is the keyword that I want to look for? And then it's going to go through, character at a time, searching for that word. And the interesting thing about string is you don't have to tell it how long the string is. It kind of figures out the length of what you're looking for. It just has to know the starting position within the string. So if I'm looking for a 5-character long phrase, I don't have to specify the length of that. It just knows that. Now, this particular program here actually kind of creates a loop and creates some counters. So as it's going through, it's going to count what position it's in as it's going through, and it's also going to count if it finds the word, and if it finds the word more than once, it's going to increment a value to tell you how many times it found that. So if we were just to look at the program and then kind of analyze the code here, so I think this one is now 30-2. So here's one example. Can you find Waldo? So that's the text I'm going to be searching through. The target in this case here would be Waldo. And as it came back, it does two things. Number one, well, let me make the screen bigger here because you can't see it. So the first thing it does is it ends up blanking off the word that it found. The second thing it does is it tells you how many times it found that word in the string you specified. I'll run through another example. We'll look at the code and then we'll break it down by what the logic's like, which I think the book does a pretty good job of too. But if I run the same program again and I say something like happy and apple and banana and other words that have the letter A in them, crap and other things that have the letter A. So just for that example here, so I got happy, apple, banana, crap, right? And now what I want to search for, A. Now we're going to see multiple iterations of the search as it keeps looping around. Here's the first A that it found in happy, and it marked that off with a character string 128, which is a black space. Here's the second occurrence of A in apple. Here's the third in banana. Here's the fourth in banana. Here's the fifth in banana. Here's the sixth in crap. And here it tells us it's found 6 occurrences. So it's taking our search string that we enter. It's then using the INSTR command to look for the criteria of what word we're looking for. It's kind of tracking the positions it's going through and telling and showing us which position that it's putting that in and kind of marking that off visually. And then it's incrementing a counter to tell us how many times it found that occurrence, right? So in the book, I think it's going to show us or explain to us a little bit more of what it did. So it says line 15 assigns S string as your search value. Line 20 assigns target string as what you're going to search for. Line 30 tells the computer to start searching for your target string at the first position in S string. And if we look at our program here, P starts off at 1, right? So P is our position. P starts off at position 1. As we go through the program, it assigns this to a integer variable. So F is the variable. F meaning found. Have you found it? So it's saying that F equals in string P is our position within the search string looking for text string. So it's looking for the text string within the search string at a given position of that string, starting with position 1 for character 1, and will increment to position 2, etc. So and so in the first case here, my first word was happy. The first letter is H. So would that return a positive value? And that answer is no, because H is not A. So this says, okay, well, this is not good. This is a 0. I'm going to go to line 60 Oh, wait, no, 60. Oh, this means what? Oh, never mind. This says when you've reached the end, if you're past the end, right? So that's another reason why I forgot about that, right? So this one says if you've reached the end of the string, that's another reason why this will return 0. So at this point right now, we're going to continue to go through here. We're looking for the position. Position 1, we're looking for this. If it equals 0, meaning that, okay, so the conditions for 0 were the string is null, we've exceeded the length of the string, or the word is not there. If any of those conditions apply, then go to the end statement here. Since those positions do not apply, we've now incremented our counter. And so at this point here, it's saying, okay, so at this point here in line 30, it's assuming it's already found what's going on here. And if it had not found anything, so let's try that example here, because I'm struggling with this right now. So let's say this. Let's say, okay, search text, you can't find me. Target text, dud. Okay, so dud was not found, right? So then it just jumped straight down to line 60, and the counter was set to 0. So it did not find those occurrences. So, but the way INSTR works here, though, is if it did find it, then the value would not be 0. It would know that it was there, and somehow it's going to know what position it's at here. And so now we are doing some crazy math here to figure out where we are in the screen. And it took me a while to follow their logic and type it in properly, because the way it wrapped on the screen was kind of crazy. But we're printing the left part of the string up to wherever F is, and F then becomes the position. F becomes a value of what field or what position we're in within the string. And so let's say it was at position 13. So we're going to print the first 12 characters of that word, and then we are going to print a strings of the target string. If the target string was apple, and apple is APPLE, 5 characters, we're going to print. We figure out the length of that. We're going to print 5 of character string 128, which is the black space, and then we're going to print the right string of the length of our string minus up to the position where we are, plus 1 more because we have to skip over that word. And so this whole logic here, very dynamic, is a way to wrap around where the word is and print to the left of the word, mask out the word, and then print to the right of the word. So it's some pretty fancy logic here. And then here's where we update the position of the thing. So the position started off at 0. And in our first path, it was looking for the position of the thing. Because we're assuming we found it at least once, we've automatically incremented our counter. So our counter has increased by 1. It started off as 0, went to 1. We are then incrementing P. P is now somewhere in the INSTR, we figured out where we are here in our P. So the position now says F plus the length of my target string. And then we're saying if we are less than the search string minus the target string plus 1, then we're going to go back to line 30 and keep searching. So it's actually incrementing a separate position variable here that is adding the length of the target string minus the length of the search string. That will continue to go through, and if we haven't reached the end of the string minus the length of the word, we're going to keep going back. And so this is a way to check that we haven't reached the end. Having a little bit of trouble following it exactly, but I am following it for the most part. But it's a really fancy, elaborate program for only a few lines of code here. And it's pretty impressive what this program has done with a few lines and what this thing has done here. So again, can you find Waldo He is hiding. Waldo does not like for you to find Waldo. All right, so extra ignored. Oh, maybe I typed in too much text, and now I'm going to type in the word Waldo. How about I type in the word you? Okay, can you find Waldo? Found one occurrence, which means I probably went too far than the 255 characters or something. I don't know. Or it just got too long. So maybe a bad example here. So can you find Waldo? Target text, Waldo. Yes, we find him. Let's run it again. So ABC, CBA, DAB, BAB, ZBA, right? That's what I'm searching for. What's my target text? A. This one seems to make a lot more sense and the computer can handle it a lot easier. I don't know what the maximum length of that string is, but I had 5 A's in my example here. So it's kind of cool. I know I'm kind of losing myself. I might be losing you, but what's really happening here is that in-string is a way to look within inside a string for the occurrence of another string, and it will pretty much tell you where it is. Let's just try a random example. So I'm going to say a string equals, I don't even frickin' know here, a string equals this is me. Now I'm going to say here, then we said f equals INSTR. So in string 1, comma, a string, comma, me. This is what we're looking for. All right. So print f. F says 9. So what the hell does that mean? I said start at position 1 in a string, look for the word me. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's confusing the hell out of me. 1, 2, 3, 4, 5, 6, 7. Maybe I need to count properly. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. So me starts at 9. So I said start at position 1. Tell me where me is in that string. And in this case here, it's telling me that me is at position 9. And so why is this helpful? Because this would help you do something like a search and replace, which is the next thing the chapter is going to do. And I'm sorry this took me a while, but even though I went through this and I ran it and I understood what it was doing, as I'm trying to explain it, I'm confusing myself. So ignore all the other parts where I sounded like an idiot. Now I sound like a little bit less of an idiot. But yeah, so in this simple example here, I created this string. I said, this is me. I said f equals in string starting at position 1 of a string, and the search word I'm looking for is me. And so it's starting at position 1 and it's going through here. If I said start at position 5, then I would be somewhere right over here where the S was, right? 1, 2, 3, 4, 5. It'd actually be in the space. So it's probably best to always start at position 1, and then this just tells you what position within the string that word starts at. So that is the purpose of this. And if it wasn't there, so if I said f equals, too bad I can't just do an up arrow to repeat that, right? So f equals in string 1, comma, a string, comma, you, right? So I'm not looking for me, I'm looking for you. And I say print f, it's going to say no, 0, because it does not apply. And 0 value will return in one of 3 conditions. One of them is the a string that I'm searching is null. Another condition would be you have exceeded the length of that string. Or a third condition would be what you're searching for does not live within the string. You have no way to know which one of those examples it is. It's just going to return that 0. But basically what you're looking for is if the in string is 0, then you know it's not in the string, regardless of the condition, right? So that is what that is all about. That's that hokey pokey right there. And so now, and again, I am not going to do the do-it-yourself ones. I'm not going to do this one here that is just another exercise in driving me crazy. It's just trying to show you the same example, the same concept using a different example. I think we get it at this point. So now we're going to go on to mid-string. And so mid-string, as the name would imply, allows you to look at the middle of a string. So we know that left string allows you to peel just the left part of the string up to a certain length. So left string is always going to start at the beginning, and then it's going to stop at some part where you say, here's the length of the left part of the string I want. Right string is always going to end on the right, and is just going to back count how many characters you want and always give you the rightmost part of that. But there's a left and there's a right. What if you want to pull some data from the middle of a string? Well, BASIC has given us a command called mid-string. And so mid-string basically says, what is the old string? So if I have a string called a string, what position is it? And then what length do you want it to be? So, so if I have an a string that says man in the middle, and I want to change the word man to something else, I could do that. Bad example, right? But so I start with the old string value. I tell it what position within that string I'm looking for. I'm telling it how long of a string I want to replace, and then I stick in a new piece of data. So I can replace some data. I can either replace some data, or I think you can actually read data from a string too. So I could say something like a string equals B strings, this position, that position, and pull back what's in the middle of that string. So old string is the variable name of the string to replace. Position is the number of position in the first character to change. The length is the number of characters to replace. If you omit the length, that will replace all of the old string. New string is the string that replaces the specific portion of the string. If the new string has fewer characters than the length specifies, the computer substitute all of new string. New string is always the same length as old string. So in the example here, just for example, I know I'm doing a really crappy job of explaining this, but I believe we are now on program number 3. Once we see the examples, it'll probably make more sense. So, and I think I need to make this big again. So as I list through here, too many screens, too many keyboards. As I list through here, in the example here that's in the book too, we say that a string equals Kansas City, comma, MO for Kansas City, Missouri. And then we go on and say that we're going to go to mid-string, a string, comma, 14. So where is position 14? Well, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Position 14 is where the M begins for Missouri. Now, in this case here, we're not even specifying a length. We're just saying, starting at position 14, replace the rest of the string with Kansas City, because we're saying we don't care what comes after this. We're just basically changing this. We could have actually used a right string to do this too, but we're saying we're using the mid-string command to replace at position 14 this. So when a string started off as Kansas City, Missouri, once we replace this, it should say Kansas City, Kansas, right? Kansas City, Kansas. That's kind of what mid-string does. So I'm trying to think of another example here. So a string equals left, comma, middle, comma, right. Now, let me count the positions here. 1, 2, 3, 4, 5, 6, 7. So starting at position 7, we have the word middle. And the word middle has 1, 2, 3, 4, 5, 6 characters. How many is in center? C-E-N-T-E-R. Center also has 6 characters to it. So again, if I go to position 1, 2, 3, 4, 5, 6, 7. So position 7, length 6, we should be able to replace that. So if I now say in line 20, mid-string, I have to edit 20. If I say mid-string, A string comma 7 comma 6 equals center, this should literally replace a word in the middle of the string. So let's try this. Yeah, left, center, right. So I started off as left, middle, right. And let's try one more thing. Let's do a line 15, and let's say that B string equals, and I want to see if I can pull or extrapolate the middle of the string. B string equals mid string, A string, comma 7, comma 6. I think that should work. Edit 15 again. Why is my freaking keyboard not working? Because I hit something on the freaking emulator. I forgot the ending thing. And then if I go back to 40, I'm going to say print B string. So we're going to see what we did here. So, yep. So in this example here, using mid string, I am actually able to, number one, replace text, where I've actually replaced the word middle with center, but I could also extract text. So if I have a piece of textual data, a text string, a text variable, and I know that this text is a certain number of characters, and I know that always at a certain position within this string of text, I'm always going to expect a certain thing. I could say, always just give me that. Just give me what's in the middle, starting at position this for this long, pull just that out. I can extract that text, stick it in another variable, and see if I'm what I'm looking for, and then I could even compare that further with INSTR or whatever else, with your greater than and less than when we went over sorting. So there is an interesting way to extract something from the middle of text. And this makes more sense to me, which is why I think I did better in English than I did in math in school. But when we were talking about two-dimensional arrays and three-dimensional arrays, while I can understand the idea of nested data and columns of data, what I couldn't understand is a way for me to apply, how can I pull something just out of the middle? If I've got this three-dimensional array and I've got three numbers in one variable, how can I just pull out the middle number? And for whatever reason, it wasn't then and it isn't now clear to me on how to do that. And I don't care. I'm a freaking idiot. I don't care. And I just, I'm trying to do the best I can explaining things as best as I'm able to understand them. So I actually like this example here. So actually I want to save this one as, I think that was, so we're going to save this one as 30-3B, right? And so that was another cool example of using mid-string to change things. I like it. I'm able to understand it. I'm not that confused about it, right? And so this is how we changed it. And so now this last program example is actually combining mid-string and INSTR to do something. So what the program is doing is it's asking us to enter in a month and day. And it's asking us to put the month followed by a slash, followed by the date. It's inputting that into a string we call X string. We're then looking for the position of X string that contains the slash. So P will equal that position. So if there is a slash within the string, it will be returned to that position, which we could use for a mid-string statement. Right here in line 30, it's going to say, though, but if P equals 0, meaning it does not exist, then go back and keep asking the question. Now what we're going to do is use the mid-string command to say that whatever position the slash was in the string you input, for a length of 1, we're going to replace it with the dash command. So we're replacing a slash with a dash. And then we're going to say, isn't this easier to read and show you what you inputted with the slash instead, the dash instead of the slash. And so it'll hopefully make more sense right now when I do it. And so as I load in, and it doesn't sort, so 30/4, I gotta spell load right, 30/4, and I run the program. Enter in a month or day. So if I put in, for example, my birthday, 5/24, it's going to come back and say, isn't 5-24 easier to read than 5/24? 24. And you know what? This is really a matter of opinion. It's more opinion than it is fact. But let's say I ran this and I just put in, screw you, not gonna do it, right? I went back and modified their code just a little bit to where it says if that P equals 0, meaning it does not exist, it says, hey, you didn't use the slash. So if I went in, and here's another thing, it's not looking to validate how long things are to the left or the right of the slash. It is just looking for the existence of a slash. So if I said, okay, so if I just said hello slash goodbye, it would come back and just replace just that one occurrence of the slash with a dash, and it would say hello dash goodbye. Is easier to read, isn't it? Again, your opinions may vary, your mileage may vary, and they're giving us another do-it-yourself program that says pretend you work for a phone company, and when the phone numbers used to be stored as letters, write a program to replace them as numbers. Knock yourself out, kids. I'm not going to do it. I'm old. I'm tired. I'm lazy. I think I fairly much understand what these commands are. Again, part of this journey of doing these is to reteach myself. And so even though I went through and I typed in the programs ahead of time and I tested the programs ahead of time, as I'm reading this out loud, I'm realizing that my own understanding needed some realignment. So I think at this point, by me allowing myself to sound like a complete idiot, I now have, at least for my own benefit, understood the purpose of string and INSTR. Nice, useful utilities, useful tools to help you extrapolate and determine things that live within inside string. Kind of ties into the previous chapter I did on analyzing, because now we're analyzing text instead of numbers, and for whatever reason my brain processes that much better than it does the number stuff. We have completed another chapter, boys and girls. We have just completed chapter 31. If I'm not mistaken, I think there's only 34 chapters. Today is June 27th. So I got 3 days left in this month. I did try to make a commitment to finishing this book this month. I'm thinking I'm going to be able to do that. I hope you have enjoyed this video, and we'll see you on the next one. Just to remind a few people or straighten out a few people, but this entire series started on my, hold on, I gotta close the door. People are walking in the house now. This series started on my original gamer channel, and it's still there, but I've moved most of my color computer content over to my new channel that's called I'm a CoCo. So because not everybody knows about both channels, and just for convenience sake, I'm posting the video in both places. So I will finish the series on my original gamer channel, OG Steve Bistro, but I'm also adding to the series on the I'm a CoCo channel. So the reason why I'm saying that is that some people are finding this video in one of two places, and you might not know that the other places exist. And there is some content that might be a cross-pollination of interest to your brains if you like the color computer. So a lot of my legacy color computer content is still there, because I was thinking about moving a lot of my gameplay videos, but then I was just thinking, you know what, some of them I just kind of am not that happy with. I kind of cringe when I watch them. And so I'm actually redoing all of my gameplay color computer videos on the new channel. So if you've liked my old gameplay videos, then the old ones are still going to be there, but I'm doing new ones, and they're going to be on my I'm a CoCo channel as well. This series will finish out on both places when I start my new series after this, which will be learning assembly language on the color computer that I'm hoping to start in July. That one is only going to be on the I'm a CoCo channel. So just for your information, for those who want to continue to follow, for those who are maybe interested in some things I've done in the past, for those of you who knew what I did in the past and maybe don't know what I'm doing presently, trying to let you know there's stuff all over the place. And so whatever channel you're watching this on, if you go to the home page of that YouTube channel, especially if it's easier to do it in a computer than on your little phone thingy, but if you go to the home page of the YouTube channel, I have put little links to all of my other channels. So all of my channels have links to all of my other channels. And so make sure you go to those and you bookmark them and subscribe to them and all that kind of stuff if you want to see that content. All right, guys, we're out of here. I don't know how long I've been recording. Feels like forever. My head's about ready to explode. But I made another video. I am continuing my hashtag of commitment CoCo, and maybe I'll see some of you guys this Saturday on CoCo Talk, the world's leading live talk show featuring the Tandy color computer that you can see on the new YouTube channel, I'm a Coconut. We'll see you then. Peace out, everybody. Bye-bye.